Hi, it's János, this is Real World Audio, and we are browsing through the list of recommendations for the Audio Club Monday subjects. So I'm going to give a sneak preview what we are going to get in the next couple of weeks. And as you see, these are the major topics that I thought would be like a good idea to talk about, and the vast majority of the votes I got was for why do I prefer tube amplifiers to solid state technology. So I'm going to expand on this a lot for the next Audio Club session, next Audio Club Monday session. In fact, actually, I'm going to make it a special week, and that will be the subject of the next week. So I will start it with the Audio Club Monday episode, and basically it will be like a single big Audio Club Monday riding throughout the whole week. And I'm going to show something very, very special, something that I have already promised, which is why the THD distortion figures that we get for solid-state amplifiers and tube amplifiers don't translate to real-life experience. How come that we have solid-state amplifiers that measure 0.05% distortion, and subjectively they sound much more distorted than tube amplifiers that have 1% distortion written on their specification sheets. And the problem is not with deniers, not that those people who say that tube amp sounds cleaner and more natural than the solid state amplifier, which on paper has much lower numbers. It's not that these people are deniers, and there are some measurement channels who would increase that mentality that yes, they are denying. I will get into that quite deeply and show that there's no denial at all. But that camp that says that what is shown in the statistics as 0.05% is lower distortion than what is shown as the 1% in the statistics for a tube amplifier. And that's because, not because 1 is lower than 0.005, absolutely not. It's 20 times higher, right? But the problem is why that 1% translates to lower audible distortion is for two reasons. Is one, that how the specification is given, and when you are listening to what is the range of distortion that you are hearing, that's number one. And that's not the same for these two technologies. So actually when you are listening, the actual volume, there you are riding close to that specified number for the solid state that you get. And for the tube amplifiers, you are actually listening to much less than that. And that's what people often forget, that when you have a zero feedback Class A triode amplifier, that 1% THD, that's given for near peak power, usually. And if you have a loudspeaker that matches that amplifier, you are never hitting 1% THD when you are listening to it. In fact, most of the material you are listening to less than 0.005% THD, or even less than that. However, when you have an unsuitable loudspeaker with your zero feedback Class A triode amplifier, then you are constantly pushing close to that 1%, and that's when people notice those problems that they say that, oh, these amps are distorting, they don't have enough power, etc., etc. And it's not the amplifier's fault, it's that stupid user's fault who is clueless about matching the amplifier to a correct loudspeaker. So it's kind of like blaming the shoemaker when you are trying on shoes that are like 5 sizes smaller than your feet. That's not the shoemaker's fault. That's the stupid person's fault who wants to who is an adult and going to the kids section to try on shoes. So that's just something like off the bat to notice. But the other thing why the THD distortion figures don't translate between a solid state amplifier and a class A zero feedback triode amplifier is that for a zero feedback class A triode amplifier, the THD is predominantly second harmonic, which means the distortion occurs very close to the note, to the sound that is closing to the distortion. So basically the distortion is riding in the shadow of the signal. And it's kind of like part of the signal. It's congruent. There's a deep connection to the signal. And in the solid state gear, the THD it stretches out to very high order distortions. It's common to have like 13th, 15th, 17th, 19th order distortions. And when you have that high distortion level, then you have kind of like, it's like an earthquake-like type of effect, that basically the distortion spectra, if it happens in the deep bass, your note is in the deep bass, then the THD spectra will reach up to the mid-range. And that's just something absolutely gargantuan, because when a note is happening, then the THD is affecting a really wide band and messing up other signals. And that also is not perceived by a computer, by an oscilloscope. So it's not measuring, okay, that was the original signal, that was 100%, and now the THD, like let's say at 19th upper harmonics, that's 0.01%. It should be inaudible, right? No, that's not the case at all. So for the computer, it will measure it as 0.01%, but your ears will tell you it's much worse than that, because our ears don't measure in SPLs. Our ears measure in phone. And the phone value of any sound related to another sound depends on the SPL, on the absolute level of one sound, and that's how we can correlate the other sound to it. And in the bass, the sensitivity of the ear is much lower than in the high frequencies. So when, let's say, at 20 hertz you have a signal, that's your main signal. Let's say you have a 20 hertz signal, and at the 19th order harmonic, it's going to cause a 0.01% distortion up there. And then you would say, that's nothing. But to your ear, it will be absolutely gargantuan. And that's why for some people, they will notice that the mid-range is not good with solid-state amplifiers. And that's the reason why I think, in my perception, that's a key reason why the mid-range can suffer gravely with solid-state amps when there is when the music gets more and more complicated. And this is really a very big subject, and I'm just piercing it because I'm going to dive into it deeply next week. So I'm just throwing out a few nuggets, and we'll fill out the gaps next week. But basically, because of we have brains that process the information, and that brains are processing the information in a very different way. We have adaptable sensitivity to different sound pressure levels occurring on different frequencies, and that's why when there is strong bass signal occurring, it causes a lot of problems with solid state amplifiers in the mid-range. Not all of them, but a lot of them. Now you need to go into every one uniquely to see what's happening, but it is a tendency that is inherent to solid state technology, that there will be a problem with those higher order harmonics creeping up into the mid-range. Now, if you are listening at a very high sound pressure level, you are rocking out to an AC/DC concert, you will likely not notice this at all, because then your mid-range and high frequencies will also be playing very loud, and it will be drowning out that harmonic distortion component caused by the low octave bass notes. However, if you are listening to classical music, where you have, let's say, a boom, like a big drum beat, a big timpani beat, and then there's a violin playing next to it, and after the beat, of course, that's really loud, but right after that is gone, you can still follow a relatively quiet violin, even not just quiet, but even a loud playing violin, very easily. That's no problem with your ears. But that distortion that the timpani beat injects into the violin's frequency range will cause major alteration to how the ear perceives that violin, and how the tonality, imaging, and just the texture in the mid-range is affected. So that's why people who listen to music which have very wide dynamic ranges, such as orchestral works, a wide dynamic range means that you have very loud and very quiet passages, and they are suddenly shifting one to the other. And of course, when everyone is playing at very loud levels, like at an AC/DC concert, it has no dynamic range, because everyone is screaming and shouting, and there this distortion problem does not come up, provided that your amp can supply the required watts to keep up that sound pressure level. And however, when you have these fluctuating dynamics, and you are perceiving quiet and then loud, and then it fluctuates with the time, then it will be very, very noticeable. So that's my little introduction, and for what is coming up, and a little primer about solid state versus tube technology. And I'm going to go much deeper into it. When is solid state technology preferable to vacuum tube technology, and when is vacuum tube technology preferred to solid state? And now I have answered this partially. So when you have like very wide dynamic range material, like classical music, then vacuum tube technology will be quite a lot preferred, even compared to a solid state amplifier that on paper says 0.05% THD or 0.005% THD, because even that low THD, because of the ear's Fletcher-Munson sensitivity curve, it will affect the mid-range very substantially. A large bass note will affect the mid-range, which is at like a mid level. Mid-range information will be entirely destroyed by a strong bass note. And I will say that how badly does it destroy? It utterly destroys it. So, for example, if you have a timpani note, the upper components, even when those upper components are 0.01% harmonic distortion, they will be larger, like 400% the size of what a violin would be playing. And the numbers you will show in the upcoming week. I will demonstrate it that it in practice, when you are looking at classical music, that really nice sheet that you are getting, 0.05% THD, that amp is crystal clear, and then you're listening to classical music, actually in practice it's 400% harmonic distortion, not that 0 point vanishing, 400% when you listen to classical and you want to enjoy a violin when there's also a timpani in the background giving the beats, like you are listening to Uno Klami or Tchaikovsky or Mussorgsky or any of these guys who wrote complex music with widely varying dynamic range. When you listen to AC/DC, when everyone is screaming, then you won't hear that at all, because that's not getting affected. So essentially, choose. What is it, the music that you prefer? AC/DC you can get much easier with solid state technology. You can get cheap, high power, find speakers easier for that. And with tube technology you can also enjoy AC/DC, but you need a tube amplifier that can put out something at the order of 20 watts, and you need loudspeaker that has the sensitivity of about 105 dB per watt meter, and then you can also enjoy AC/DC on that. So that's my little sneak preview, and see you next week. Bye bye.